Hey class, it's, what is it? It's the day one homework from topic two. That's what it is. And we'll go right into it. Um, this is back in the power function stuff. So here you can see it's just asking you to determine if you're a power function. And if you are, um, then you have to state the power and the constant of variation. Pretty easy stuff. So for the first one, is this a power function? Again, your decision is just based on whether the coefficient is a real number, which, I mean, you can scan all of these. All of them are. There's nothing here is imaginary, and that's what it means to be real, is you're just not imaginary. So all the coefficients are fine. So the only other rule then for being a power function is you'd have to be of the form k times x to the a. So you know what, let's just go through it. So 3 is not a power function because instead of having x as its base and some constant value as the power, it has some constant as the base and x is the power. So number 3 is exponential, which is not a power function. That's a completely different type of function. 13, and we'll talk to that one we'll talk about that when we get to it. But for number 1, we can see that fits the bill. The negative 1/2 is our constant, and that's fine. We do have x as a base. We have a power of 5. So, yep, fine. We said the only stipulation on a power function was that the power had to be a real number. It could be any kind of real number. The one thing it couldn't be was what? Couldn't be 0, because then it would be a constant function. And to my understanding, power functions, constants are still not power functions. So looking at this, we're saying yes, that it's a power function. The constant of variation is the negative 1/2, and the power is 5. The power being 5 on a different assignment, we said, also decide whether you're a monomial. So this thing would be a monomial because that power there is a whole number, meaning it's an integer that is positive. So this thing would qualify as a monomial. It's not a constant function because it's got x to a power. All right, what about 2? We've got the 9x to the 5/3. So yes, that's a power function, because again, the power in a power function can be almost any number that it wants to be. It can't be imaginary and it can't be 0. But other than that, whole numbers are fine, fractions are fine, anything's fine. So this is a power function. So this is another yes. The constant of variation is 9, and the power is the 5/3. We already said that number 3 was an exponential function, not a power function, so that's a different class. And for number 4, that's a constant, which I still believe is not a power function, because the 13 would be 13x to the 0. And I'm pretty sure we want to bar 0 as one of our possible powers. So there you go. That's those 4. And then I think there was 4 more. Oh, there's 6 more. Okay, I'm going to go a hell of a lot faster then. So E equals mc squared. The only tricky bit here is just recognizing which thing is the constant. So for number 5, c squared is your constant. So you might want to rewrite this to where e is a variable, but c squared is the constant, and m is your next variable. So does this fit the bill as a power function? Yes, it does. This is still the same instructions, right? Yeah, 1 through 10. Okay. So the power on m would be a power of 1. So is this thing a power function? You say yes. The constant of variation is c squared. You got to actually say c squared, not just c. Obviously c squared is different from c. Those are different values. And the power, well, the power is 1. So that's it. I'm looking at 6. I'm not a scientist, but this looks like it's probably kinetic energy as a function of velocity or something. So kinetic energy, Ke, is going to be our y variable. 1/2 k. K is our constant. You'd have to look at the directions to know that. But in the directions, it's straight up telling you that k is a constant. Otherwise, maybe you would wonder if that's the variable, but it isn't. It's the constant. Our variable here is v. So 1/2 k, or k over 2, however you want to put it. I'm going to put it k over 2. But k over 2 would be our constant of variation, right? Our coefficient. And then v is our variable to the power of 5. So this is another power function, so you're saying yes again. Constant of variation is k over 2, and the power is 5. Okay, for 7. Excuse me. Again, looking at this, I don't know what these variables are. G is gravity, T is probably time. Is D distance? Can't be. I don't know, man. But whatever. D is our variable. 1/2 G would again be our coefficient. So G over 2 is fine. Half of G, I don't care. But that'll be T squared is our variable. So looking at this, is it a power function? Yes, it is. Our constant of variation would be half of G, and our power would be the 2. Easy peasy. 8. Alright, I recognize that. That's the formula for the volume of a sphere. So, V is for volume. That's a variable. 4/3 is looking like a constant to me, but so is pi. So 4/3 pi would be the constant of variation. All of that stuff. And then r is our x variable. It's getting cubed. So is this thing a power function? Yes. What's the constant of variation? 4/3 pi, or 4 pi over 3, however you want to put it. I like the sound of 4 pi over 3. And what's our power? Our power is 3, because we're cubing that variable. Alright, what about 9? I'm getting a little low on space, but I'm okay. What is 9? An I and a D? No idea what that is. I don't care. Is that a power function? Yes, but I would rewrite it if I were you. This is I equals some coefficient k multiplied by d to the -2. As soon as you rewrite it with the negative exponent, it should be obvious that yes, we're a power function. Our constant of variation is the k, but our power is -2. If you didn't rewrite the function, if you were working off of this form up here, then you're likely to tell me that the power is 2, but it isn't. Its power is -2 because that expression's in the denominator, so don't screw that up. Okay, here's an equation I know. Force equals mass times acceleration. So force is a variable, mass is a constant, and acceleration, actually I don't know. Which one are we treating? Better go back here. It doesn't say. So I would assume that mass is the constant then. Yeah, it would only make sense for mass to be the constant here. So whatever. Is this thing a power function? Yes. What's the constant of variation? The mass. What's the power? Well, the acceleration is to the power of 1, so I guess it's 1. Alright, hopefully that's a piece of cake. In the next few problems, we are now determining whether the function is a monomial function. And for those that are monomial functions, we're stating the degree and the leading coefficient. For those that are not, explain why. Again, to be a monomial, you have to be a polynomial. And to be a polynomial, your powers have to be whole numbers. So for us to be a power function, we said our exponents could be basically anything they wanted to be. So in the first batch, like we saw that 5/3, we didn't care. Didn't matter that it was a fraction. Fractions were allowed. In the second batch, we saw a negative exponent. That was fine. Power functions don't care if the exponents are negative. It's no big deal. But to be a monomial, you got to be a polynomial. To be a polynomial, your powers have to be whole numbers. So looking at something like 11, technically we would rewrite this as f of x equals. -4 is our coefficient, and there's an x here. It's just going to be x to the 0. And 0 is a whole number, because whole numbers are positive integer values and also 0. 0 is a member of the set of whole numbers. So for this you should be saying yes, it's a monomial. Then you're giving me what? State the degree. Okay, so the degree is 0. And then you give me the leading coefficient. Leading coefficient is -4. Okay, whatever. Let's do 12. For 12, I see a negative power, so we are not a monomial. You could rewrite this if you wanted. It would be 3 over x to the 5th. And you guys are all experts now, so you know that a function of that form is a rational function. That's not a monomial. Monomials have to be polynomials. So this is slash not a monomial. 13. Yeah, that's a monomial. Negative coefficients are fine. You just can't have negative exponents. So this guy is a yes. The degree is 7. The leading coefficient is negative 6. 14. Not a monomial. This is a another exponential function because the base is now the constant and x is the power. So not a monomial. Just for the sake of argument, it's an exponential. Wouldn't care you to write that down so that you might actually remember it in the future. And speaking of that, 12 we said is actually a rational function. You might want to write that down. Looking at 15, that's the surface area of a sphere, and it is a monomial. So yes. Then you're supposed to give me the degree. The degree is the power on the variable r. Radius is our variable, so the power is 2. And the leading coefficient would be 4 pi. Not 4, not pi, but 4 pi. Both of them multiplied together. 16, that's the area of a rectangle. So this one's a little weird. L and W would technically both be variables, right? But it says right here that we're supposed to treat L as our constant. So that would mean yes. This is in fact a monomial. And the power would be 1 because we're looking for the degree of L. L is being raised to the power of, oops, super psych, doesn't matter. But we want the power of the variable. So the exponent on W is 1 and the leading coefficient is L. Okay, we did it. That's it. That's a whole homework down. That was day 1, topic 2. Let's do the next one. Alright, so here is where we were getting into the language of variation, talking about things varying directly with one another, or varying inversely with one another, or being directly proportional, or being inversely proportional. So looking at 17, it says the area A of an equilateral triangle varies directly as the square of the length S of its sides. So any direct variation has to take the form of y variable being equal to some constant value multiplied by x variable. That's what a direct variation will always look like. So now all you got to do is slide in the right, variables, the right letters. So area A would be our y variable, and it varies directly with the square of the length of the side. So it varies directly with s squared. So the only thing we're missing is that constant of variation k, which you just, since no other constant was stipulated, you will use k, like it says right there. But that's it. That would be the equation modeling this variation. The next one says the volume V of a circular cylinder with fixed height is proportional to the square of its radius r. I don't love this. If they don't say directly proportional or inversely proportional, then I think it's understood that it's directly. So directly proportional is the same as varying directly. So you'll set this up the same way, where your y variable v is equal to, they're not giving us any constant of variation, so we'll use k. Fixed height is proportional to the square of its radius. So it's just, that's going to just be multiplied by r squared. That's it. That's all. And there's no more to it than that. You're writing that equation and move on. So moving on. So now it says the current I in an electrical circuit is inversely proportional. Okay, fine. So that's a new one. If we are inversely proportional, then that means the y variable is going to be equal to some constant of variation divided by the x variable. So in general, that's your inverse proportional setup. So that means the current I is equal to the resistance R. So they are stipulating a constant of variation here. So don't say K divided by, say V divided by. The resistance R. But that's it. It would just be 1 or I equals V over R. It didn't stipulate that it's the square of the radius or of the resistance. There's no other operation, so we're done. Charles's law. You maybe remember that from chemistry. Looks like I'm not framing my head in frame correctly. Maybe that's okay. Maybe no one cares. But it states that the volume of an enclosed ideal gas at constant pressure varies directly as the absolute temperature T. Okay, fine. So another varies directly one. Those should be easy. You're saying volume is equal to some constant K multiplied by the X variable, which I guess is T. That's it. Those are easy. So yeah, you're done. Next one. The energy E produced in a nuclear reaction is proportional to the mass m with constant variation being c squared, the square of the speed of light. Alright, fine. So energy is equal to some constant times the other variable, because this is directly proportional. So the constant of variation is your c squared. You're going to multiply that by the other variable, which is mass. And so this is our equation. But yeah, its more famous form would be mc squared. But I don't want anybody to get confused because we are memorizing our rule as what? Y equals k times a. I don't mean a. I mean x. So if you write it in the form of E equals mc squared, just don't trick yourself into thinking that m is the constant and c is the variable. This might be the better way to write it, just because it better matches our form, that the constant of variation is c squared and the actual variable is x. Okay, 22. The speed of a free-falling object that has been dropped from rest varies as the square root of the distance d with a constant of variation k equals square root of 2g. So speed is p. It varies as the square root of the distance d with a constant variation It just says varies? Alright, then I guess it varies directly then. I'm definitely not framing my face in. It's actually bothering me. I know you guys don't care. I'm going to pause. Let me pause. Alright, I don't know that that's better. That might be worse. Anyway, p is my variable. It should be equal to the constant of variation, which is square root of 2g, multiplied by the other variable, drop from a height, varies as the square root of the distance traveled. So that's square root of d. But there it is. I think the only interesting thing here is that yes, you can put those two radicals together into one radical. So 2g is our constant, d is our variable. But p would equal the square root of 2gd. You could put it all together, kind of simplify it into a nice, neat answer. But moving on. 23. This time you have to write your own sentence. It says write a sentence that expresses the relationship. Okay, fine. So I see w equals m times g. M is my constant. So I can see that w varies directly with m. Where w and m are the weight and mass of an object. Okay, so just make sure you write out every word that you can. So you would say the weight of an object. And you'd say varies directly with. And it varies directly with m, which is the mass of the object. And technically you could stop there, but since they went through all the trouble to define what the constant of variation was, we should probably address it and say the weight of an object varies directly with the mass of the object with a constant of variation. Equal to acceleration due to gravity. Okay, whatever. Moving on to the next one. C equals pi d. Circumference equals pi times diameter. So obviously you'll say circumference varies directly with. diameter. With constant of variation equal to pi. I can't spend too much time on this. Pretty simple. Moving on. 25, N, C, and V. N is the refractive index of a medium. V is the velocity. And C is the constant velocity of light in free space. Okay, so we can see that this is N equals C over V. C is the constant. So we are dividing by our variable. That means this is an inverse variation. So we have to describe it as the refractive index of a medium varies inversely with v, the velocity of light in the medium. With constant of variation equal to c. C being the velocity of light in free space. I don't feel like writing all that out, but technically you should. All right, next, it says d is distance traveled, p is the speed of the object, and g is the constant acceleration due to gravity. So for this one, even though it looks like a fraction, the denominator is actually our constant of variation. So rewriting this, 1 over 2g, that's our constant of variation, and we're multiplying that by p squared. So this is actually a direct variation. I know it's a fraction, but it's not an inverse variation. It's a direct variation because the denominator was our constant. When the denominator was our variable, that's when we had an inverse variation. So 25 and 26 are pretty different. So here we're going to say distance traveled by a free-falling object. I can't write this out. It's 10 o'clock at night on a Friday. I'm not doing it. But distance traveled by a free-falling object is what we should be writing. But it varies directly with p is the speed of the object. The speed of the object. Super psych. You can't just say speed of the object because there's an operation involved. It's the square of the speed of the object. So you do have to put in the square part. So distance traveled varies directly with the square of the speed of the object. With a constant of variation equal to and g is the constant. Alright, I guess the constant of variation would be equal. I guess I'll just write the whole thing out. 1 divided by 2 times g. If you're wondering why I was hesitating there, I was trying to think of a fancy way to explain it. It's not half of the force of gravity, because gravity is in the denominator. It's the reciprocal of 2 times the force of gravity. I was thinking of saying that. You want to say as much as you can in words. So maybe it would have been better to say this in words as, the reciprocal of 2 times the force of gravity. But, I don't think I care. If you just give the expression as 1 over 2g, that's fine. Moving on. Ugh, there's more. Alright, it says describe how to obtain the graph. So we're talking about transformations now. So for this function, we would define g of x as x to the 4. And we see the only transformation here is that 2/3. So the only transformation would be a vertical dilation by a factor of 2/3. That's it. Is there more here? Yeah. It says state whether the function is odd or even and sketch it. So we are sketching. So these questions are worthwhile then. because we'll be asking you to sketch on the quiz. So what do we know? We know that because we have a coefficient of 2/3, we can plot the point 1 comma 2/3 if we really want to. And we know we're going to pass through that point. Because our power is greater than 1, we know that we'll pass through the origin. And because our power is greater than 1, we know that we'll be concave up. So you should see a right side branch of this graph that looks essentially like the side of a parabola. Then, because that power is even, we know this graph has even symmetry. So the left-hand side of this graph should just be a mirror image of the right-hand side over the y-axis. So that should be a decent sketch right there. Going on to the next one. This would be, we would let g of x be x cubed. And again, the only transformation would be a vertical dilation. This time it'll be BAFO 5. Yeah, that's right. Okay, so then sketching this thing's graph. Again, we've got a k value of 5, so we know we pass through the point 1, 5, which would be up here. We know that we have a power greater than 1, so we do pass through the origin. We know that our power is greater than 1 also, so we should be concave up. So basically the right-hand side of this looks just like the right-hand side of this. But because my power is 3, which is odd, the graph will have odd symmetry. So you want to reflect this half, reflect it over the y-axis, but also reflect it over the x-axis to get this graph here that has odd symmetry. Next. So for 33, I don't feel like describing the transformations anymore, but I guess I will. We know that we would define g of x as being x to the 5th. It has to be a power function with the same power. We see that this has two transformations involved. It would be a reflection over the x-axis. And then you'd also have your vertical dilation by a factor of 1.5 is the same as 3/2, so I'm going to say 3/2. But that's it, and then we're supposed to sketch this guy's graph. So here we see that with a k value, a coefficient of negative 1.5, we know we're going to pass through the point 1 comma negative 1.5, which kind of immediately telegraphs that our branch isn't going to live up here in quadrant 1. It's going to live down here in quadrant 4. But again, we see that our power is greater than 1, so we would have had that concave up shape, but since we got reflected, we're going to come down and be concave down. And because our power is odd, we'll have odd symmetry, so reflect this over and then reflect it over again, and you'll get this shape. And so there's your whole graph. It looks kind of like a cubic function. Okay, next one, we are going to go ahead and let g of x be x to the 6th. And again, we see two transformations. We're reflected over the x-axis and we're vertically dilated by a factor of 2. I am not going to write all that out. It's basically the same as we did for 33. So our graph, is that meaningfully different? Not really. With the coefficient of negative 2, we know we pass through the point 1 comma negative 2. So again, our right-hand side will be down here in quadrant 4. And again, because our exponent is worth more than 1, we would have been concave up, but we got reflected, so we're concave down. And now that 6 is even, so you know you want to take this branch and just reflect it over the y-axis only. And we get kind of this downward opening parabola. So there's that. And then there's more. For 35, there's the one transformation. It's a vertical dilation by a factor of 1/4. That means it's going to compress the graph. So to sketch it, we pass through the point 1 comma 1/4. Because the power is greater than 1, we also pass through the origin. Because the power is greater than 1, we're going to be concave up. And because the power is even, the graph will have even symmetry, so just reflect it over the y-axis. This is getting very repetitious and boring. All right, next one. Babadoo, babadoo. We can plot the point 1 comma 1/8. The power is greater than 1, so we're concave up. But the power is odd, so we have odd symmetry, so reflect the other side down. There's 36. I think we're going to do more interesting examples of this in homework 3, right? So I'm just going to blast through those. So here comes homework 3. And homework 3 is where you have to really focus on these shapes. And it's a little harder. But let's get to the homework and just do them. Here you're being asked to graph this one. So your thought process should be the same. I still think the first thing to look at is K. It's negative, so you're going to be down here in quadrant 4. So you're only looking at these guys, the E, F, G, and H's, not the A, B, C's, D's. But what else do we know? We know that we pass through the point 1 comma negative 2/3. We know that because our power is not 0, I've been saying because it's greater than 1, but it just has to be not 0. And then your graph will pass through the origin. I think I just said that wrong. What I meant to say was, we'll pass through the origin as long as our power isn't negative. So the only way to get shape A, essentially, and shape H is with a negative power. And those are the only shapes that don't go through the origin. So as long as your power is greater than 1, exactly 1, less than 1 but positive, you'll pass through. Now what's our power? It's 4. That's greater than 1. So we're going to have a shape reminiscent of shape B, but we got reflected, so we're looking at the shape of graph G, coming down like this. And again, 4 is even, so reflect it with even symmetry. So our graph should essentially be the graph of G, and then it should have even symmetry, so you can bump it across and sketch your graph. Alright, my dog has arrived, if you haven't noticed, so I gotta let him out. Hang on. Okay, dog's in the backyard. He's safe and happy. Shrink. Let's do 38. For 38, am I answering everything I'm supposed to answer? Match the equation to one of its curves? Yeah, I guess I am. For 38, I'm actually doing more than you're being asked to do, which I'm happy with. So we've got this 1/2 thing, so we know we can plot the point 1 comma 1/2 would be about here. This time our power is negative, so we do not pass through the origin. And that alone kind of tells you that we're going to have the shape of graph A. So we are going to get this hyperbolic branch that comes down, 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 and goes like that. Alright, well what else? If you ignore that negative, or if you simply break this down, this could be 1/2. If you break this off, then you could let this be x to the -1, which is 1 over x. And then you could bring the 5 out as a power. Now that 5 is clearly odd. And so we're going to have odd symmetry, so the other branch of the graph would be over here. So we're matching our graph up with sort of A for its right-hand side, and then it has even symmetry. That's how we find the left-hand side. Super psych. I meant to say odd symmetry. So bounce it over the y-axis and then over the x-axis too. Alright, the next one, 2x to the 1/4. If you can't read that, it's 2x to the 1/4. But again, thought process says that the 2 implies that we pass through the point 1 comma 2. So that implies that we're in quadrant 1. So we're definitely looking at A, B, C, D, and we're not looking at E, F, G, H. Then you look at your power. It's positive, so we do pass through the origin. It's positive, but it's less than 1. And that's the territory of shape D, a concave down graph. So I can connect these dots, but I'm going to do it making sure that the graph that I show it is concave down. Then what about my symmetry? Well, we've got a fractional exponent, so you could rewrite this as 2x to the I don't want to break it down like that. That's wrong. If you've got those fractional powers, what you want to do is turn them into roots. And the denominator becomes the root that you're taking. So if I have a denominator of 4, then I'm taking the 4th root of x to the 1. And that should jog your memory. I'm taking an even root. And square roots of negatives were non-real, right? So 4th roots of negatives are going to be non-real too. And that means this graph has no left-hand side. That's why when I added in these directions, I said, draw the left side too, if it has one. This one doesn't have a left side. So if I asked you to match this thing, you would say it's a good match for shape D, but it's non-real on x is less than 0, so there's no other half. So maybe you'd say neither even nor odd. So you just stop there. Next, for this one, coefficient is -1, so we plot the point 1, -1, and we see that we're down here in quadrant 4. So we're probably going to be getting shape E, F, G, or H. What else? We look at our power now. That's 5/3. 5/3 is greater than 1. I know it's a fraction and all, but the numerator is bigger than the denominator, so we're greater than 1, which means when we're greater than 1, we would normally get shape B, the concave up one, but we've been reflected, so we're going to be looking at shape G, and we do pass through the origin. So we can connect those two dots to get our right-hand side. Now what about our left-hand side? Well, both numerator and denominator here are both odd, so that's a pretty strong indication that we're odd. This might need a little more explaining though. This will be what? The negative would be on the outside, but we would turn this into the cube root of x to the 5th. And then because the root we're taking is odd, we can take odd roots of negatives, so our left-hand side will exist. Then you turn to this power, the 5, and because it's odd, our symmetry will be odd. So instead of just bouncing over the y-axis, you'll bounce over y and then also bounce over x. And you'll show me that sort of telltale odd symmetry behavior. But that's the graph of 40. And then for 41, we have a negative coefficient, so we know that we'll pass through the point 1, -2. So we'll be in quadrant 4. So we're looking at E, F, G, or H. Then you look at your power, and your power is negative. And that's these black ones, the hyperbolic shapes. So we know we're looking at the shape of H. It's going to be asymptotic, passes through, asymptotic again. That's your right-hand side. Do we have a left-hand side? Let's see. This is just a negative power, so that's the same as having -2 over x squared. So yeah, we have a left-hand side, and because this is squared, it's going to be even symmetry. So we'll go zoop, and we should just be mirror images over the y-axis. And then lastly, we've got 42. And so again for 42, we've got this coefficient of 1.7, so we could plot the point 1, 1.7, would be here-ish. And our power is not negative, so we do pass through the origin. And our power is less than 1, so we should be concave down, like a radical function. Speaking of radical functions, this literally is a radical function. It's 1.7 times the cube root of x squared. So again, you check the index number first, and because it's odd, we do have a left-hand side. We will get real values when our inputs are negative. Then you look at the numerator, which is even, and that implies we have even symmetry. So just bounce this guy over. And you should have two sort of branches of what looks like a square root function, both concave down. Both are concave down. And that's it. And it has even symmetry. That's all I was trying to think of to say. Alright. Sorry my chin kept getting cut off. Sorry you had to look at my forehead. But I think I'm done, right? I'm done with day... rats, I'm not even done. Okay, fine, I'll keep going. What are we doing here? State the values of the constant and the power for the function. Describe the portion of the curve that lies in quadrant 1 or 4. Determine... So we're just doing all the same stuff again. I think here, though, we're not necessarily sketching. They want you to literally use words to describe it. So for 43... I would still do a sketch first, I guess, and then convert the sketch into words. So what's happening? We're positive, so we're in quadrant 1, that's for sure. Our power is 1/4, so that means we're going to get this concave down shape. And then because the denominator is 1/4, which is even, we're taking a 4th root. 4th roots of negatives are imaginary, so I should have no left-hand side. So this is the whole graph right here. So describe the rest of the curve, if any. Describe the portion of the curve that lies blah, blah, blah. So I guess for this one you should say f of x is in quadrant 1 increasing and concave down and non-real on negative infinity to 0. How about that? That's a good fancy way to say the graph has no left-hand side, is to just say it's non-real on negative infinity to 0, meaning there's nothing over there. That's a pretty good answer. I think I'm happy with that. And my dog wants to come back in, so let's get him. Here he is. That's the dog. He's a good boy. He's a good boy. Okay, go to bed. Don't worry, go to bed. He's leaving. Back to work. Alright, I did 1. 5 more. The dog's back. What do you want, man? Okay, the dog's tired. I sent him to bed. So 44. We have a negative coefficient, so we know we pass through the point 1, negative 4. We know we live in quadrant 4. Our power is less than 1 again, so we know in quadrant 1 our graph would have been concave down. In quadrant 4 our graph will be reflected and it'll be sort of concave up. But there's our shape in quadrant 4. Then what? To break this down, the negative 4x to the 2/3, that's the same as negative 4 times the cube root of x squared. So again, like I said, base your decision about whether your left-hand side even exists or not on your denominator. Your denominator is odd, and odd roots are real for negative values. So our left-hand side does exist. Then base your answer for evenness or oddness on the numerator. That's a 2. That's even. So we should take this branch and reflect it over the y-axis. And that's going to be our graph. So then describing that in words, you'll say f of x is in quadrant 4, is decreasing and concave up and has even symmetry. So you don't have to describe this other side. If you were going to describe this other side, you would say it's increasing and concave up. But if you just describe the portion that lives in quadrant 4, which is literally what it says to do, and then tell me that we have even symmetry, then I already know what the other side looks like, because I know what even symmetry means. So you just have to describe the right-hand side, and then state what kind of symmetry we have. Okay? So that's it. I did not set this up, so hold on. Let's duplicate this a couple times. Dupe. I don't know why duplicating takes so long. Duplicate. Alright, so now I can clear this. And we can do it again for 45 and 46. So for 45, we've got negative 2x to the 4/3. How's that different? It's not. That's just literally the same as 44. 44 has a negative coefficient and a power of 2/3, which is even. Oh, I lied. It's different. Okay, 2/3 was less than 1, and 4/3 is greater than 1, so our shape will be different. But the negative coefficient means we'll be down here in quadrant 4 again. The fact that our coefficient is greater than 1 means that in quadrant 1 we would have been concave up, but we're reflected, so we're going to be concave down. But again, the odd denominator means that yes, our left-hand side exists, and the even numerator means we'll have even symmetry. So there's our overall shape. And to describe it in words, you would say the portion of the graph in quadrant 4 is decreasing in concave down, and the graph has even symmetry. And I refuse to write that down. You write it down yourself. Looking at 46. We've got 2/5 as a coefficient, x to the 5/2. So this time, our leading coefficient is positive, so we'll pass through the point 1, 2/5, and we'll be in quadrant 1. 5/2 is greater than 1, so we're going to be concave up again. And this time our denominator is even. So we're essentially taking square roots. And the square roots of negatives are going to be imaginary. So this is another function that has no left-hand side. So if you were going to describe this, you could say the portion of the function in quadrant 1 is increasing in concave up, and the function is non-real on the interval of x's from 0 to negative infinity. So that would describe 46. And then for 47, I see that negative power, so I know that we're going to be hyperbolic. So the positive leading coefficient means I'm going to be in quadrant 1, but the negative power means I'm going to be a hyperbola. And then ignoring the negative, a power of 3 is odd, so we're going to exhibit odd symmetry. So there's your sketch. If you had to describe it, you would say the portion of the graph living in quadrant 1 is decreasing, concave up, and asymptotic to the y-axis and the x-axis. Probably the easiest way to put it. You could also just literally say it's a branch of a hyperbola that is asymptotic, vertically at x equals 0, asymptotic horizontally at y equals 0, decreasing, concave up. You got all that good vocabulary that you could use. And then you just say, also, the graph has odd symmetry. And then you've nailed down the left-hand side. So finally, 48, we get f of x equals negative x to the negative 4. Negative leading coefficient means the branch to the right will be in quadrant 4. More specifically than just being in quadrant 4, it'll pass through the point 1, negative 1. But again, we've got a negative power, so we're going to be hyperbolic. So we'll come running up the vertical asymptote, turn, run along the horizontal asymptote. There's your right side branch. And again, ignoring the negative, we've got an even power. So the other half of our graph should just be a reflection over the y-axis. And there's your whole graph. So you would say, the stuff I said over here, you'll say the portion of the graph in quadrant 4 is increasing, concave down, asymptotic, blah, 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 hyperbolic, and then you'll say the graph has even symmetry, and that describes the other side. But I think that's it. I think that does it for topic 2. Obviously, the quiz that you guys are going to take, I guess it's Tuesday now, is going to cover topic 2, all 3 days. And it's also going to cover topic 3, but only the first 2 days. So days 1 and 2 only. So this video focused only on these things, and I'm going to make and post a video for the other topic soon. But maybe not tonight. I'm trying to just kind of chill for a while now. So there you go. A video for topic 3, days 1 and 2 is coming shortly. I shouldn't say shortly, tomorrow. Leave me alone. Have a good weekend. Talk to you guys Monday. Bye.